Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of March 17th. This time around, we're getting well into the spring sky. It starts out pretty moon impaired, okay? We had a lot of moon stuff going on last week. The moon's still pretty full to start the week. By the evening of the 19th into the morning of the 20th, and we're mostly talking about the morning of the 20th here, the moon has waned away to be about 2/3 full from starting the week up, 80 or 90% full. And so it's waning as the week goes on. It will be approaching Antares for where I am in the middle of the United States. It will get within about 3 degrees. Remember, that's about 1/3 of a fist width at arm's length of Antares before daylight overcomes it that morning. So it'll be approaching Antares that direction. If you live further west from me, you'll see it get even closer to Antares. Antares is the bright, bright orange star in the heart of Scorpius. So it's the brightest star in Scorpius, beautiful star. Antares, the rival of Mars. And so it has the brightness and the color that makes it a rival of Mars. Interesting star. From there, it moves on over into Sagittarius. Sagittarius is here. Scorpius is here. So Sagittarius, it sits on the tail of Scorpius. And Sagittarius typically looks like a teapot. I don't do a very good job of drawing things on the board typically. Those of you who go way back, who've been watching these for years and years and years, know that I used to try to do all these drawings before, while we were doing the video live time, and that was just chaos. So I try to put them on here before. I think this is one of my better drawings, this drawing of the teapot asterism. So we usually think of the teapot of Sagittarius. We're looking right toward the center of our galaxy here when we look down in the direction of where Sagittarius meets Scorpius. And by the evening of the 21st, morning of the 22nd, we're really talking about the morning of the 22nd now. The moon is 50% full, and the moon has moved into what would be the spout of the teapot in Sagittarius. Caus Medea is this star right here. It'll pass within about 3 degrees of Caus Medea here. It's a relatively bright star. All of these stars are sort of third magnitude stars to second magnitude to third magnitude stars that make up the teapot asterism of Sagittarius. That's the 21st into the 22nd. We go over here and the moon will have faded away. A day later, it will be over here and be somewhat less full, 40% full a day later. I don't think I wrote that on the board, but it'll be 40% full, and it'll be in the handle. There's your teapot. There's the body of the teapot. There's the lid. There's the spout. The handle's over here. And on this day, it'll get within 2 degrees of Tau Sagittarius. And so Tau is one of the fainter stars at 3.3 magnitude. Right there. Nunki is this star, a nice bright second magnitude star that is in the handle. Acela is this star right here that is a 2.6 magnitude star, and the moon is sitting right in that region. So it'll be closest to Tau of all of those stars, but it's going to be sitting right in the handle of Sagittarius. We watched Mars. We've been looking at Mars for a long time. Just keep an eye on Mars. Mars this week will tend to look like a right triangle or approaching a right triangle with Castor, Pollux, and Gemini, and then Mars. So it's moving to where it becomes a right triangle. Over the coming weeks, it's going to move out here to where it makes a straight line with Castor and Pollux. And if you think way back, we saw Mars is in prograde motion. It's in forward motion, moving easterly against the background stars. Normal motion. We've caught up and passed it, and we're well past it in our orbits now. And so now it moves back to its typical motion. But if you think back to last year, we watched Mars move this direction in retrograde motion, and it formed a line with Castor and Pollux at that time, and now it's just undoing that retrograde motion and headed back that way. So if you've been watching this is a rewarding thing to do. It's a rewarding, fun thing to do, even if you haven't been watching it, to watch Mars go from making a right triangle to making a straight line with Castor and Pollux. But you watched it happen once before if you've been watching this since last year. So these are good, fun, long-term projects, some of these things that you can be observing out here, and I recommend that sort of thing. It's a big week. You know, every week is a big week. This is a fun week. As we watch Mars unfold here, we watch the moon move past bright Antares and into the teapot asterism of Sagittarius, and we can think about those stars. But we're going to turn our attention to Hydra. We've talked about Hydra once or twice before in these videos. But it's a good constellation to be thinking about and stuff to be working on. And what we want to think about here is to say Alphard is the brightest star in Hydra, the alpha star in Hydra, and it sits about 23 degrees below Regulus. Remember, Regulus is the brightest star in Leo that sits at the base of the backward question mark, the asterism that marks the head of Leo. Fun fact, for me, that's always looked like the tail of my cat that way, so it looks like the tail of the cat instead of the head of the cat to me, but then the cat would be backing across the sky, and that makes no sense to anyone. So we'll just stick with the regular interpretation that that's the head of Leo as it marches across the sky, and that's Regulus right there at the base. 23 degrees, remember your fist at arm's length, we've said it just a moment ago, or implied it just a moment ago, it is about 10 degrees, is that angle across there. So 2 to 2.5 fist widths down, you come to Alphard. Regulus, 1.4 magnitude. Magnitude system counts backwards. Smaller number is brighter. A factor of 2.5 in brightness with each step. And so these are relatively close to the same brightnesses of stars, and they're both pretty bright stars. Any star that's first or second magnitude, if you have any kind of dark skies at all, no trouble seeing them. For me, Alphard looks significantly fainter than Regulus because it's far enough south. So I have to look through more atmosphere and closer to the horizon. But we drop down there. Now, when we drop down there, let's move to the east a little bit, the south and the east, left, if you will, if you're in the north, facing south. About 11 degrees, about a fist width down, you come to 3.6 magnitude. Now, that's a star that's getting to be a little bit harder to see. Should still be visible. That's Lambda. And another 10 degrees down to Nu. That's a 3.1 magnitude star. So those stars get harder for me to see because they're in more atmosphere looking to the south. We go 16.5 degrees the other direction, so a fist and a half up the other direction. So where we're making a triangle with Regulus, and you've got Zeta. And the Zeta is a fairly bright 3.1 magnitude star, higher in the sky for me, easier to see. And so Zeta is part of the head. Hydra, oh, so much fun stuff to think about, right? Hydra is the biggest constellation in the sky, and it is the longest constellation in the sky. As a water snake, it's this long constellation that stretches over 100 degrees, okay? So horizon to horizon, we're talking about 180 degrees straight across, if you just went straight across horizon to horizon. And so that's a huge constellation, and we're just seeing a tiny part of it. But that's just what we're seeing is huge. It's 20 degrees and another 16.5 degrees up there, 35, 36 degrees, just in that part that we're looking at. But it stretches way on down this direction, and maybe we'll talk about that sometime. We never do. I always say we will, and we never do. Maybe this time we'll talk about the rest of Hydra as we work through spring here. But you've got Zeta up here, and Zeta is part of this group. I've blown it up here a little bit. It's this part of this knot of stars that marks the head of the snake. Zeta is a nice bright 3.1 magnitude star. You've got Eta that's 4.3 and kind of hard to see. Delta is 4.5 and kind of hard to see. If you got good dark skies, no problem. But otherwise, a little bit hard. Sigma 4.1, not the brightest star to see. The other brighter star in there is Epsilon. You got this quadrilateral. A Rho was on the way. So you go from Zeta to Rho, 4.3 magnitude. Then you've got this sort of quadrilateral of stars that mark the head up there, the head of the snake. Epsilon is a 3.4 magnitude star. It's a multiple star system. We love it. We like to talk about multiple star systems. You can see them with a small telescope typically, and it doesn't matter if you have moon interference or not. The AB component is separated by only 2/10 of an arc second. An arc second is 1/3,600th of a degree. You're not going to see that with your telescope. You're not going to see that with just about any telescope unless you're at the top of a mountain and have really good skies and maybe adaptive optics. But it has a C component that's 3.1 arc seconds away. That is seeable. That is resolvable. It's 7.8 magnitude, so it's kind of faint relative to the bright pair that makes up the primary component of this multiple star system. So it's a challenge. You got your telescopes, worth trying. It's worth trying. 19.3 arc seconds out is the D component of this system. Now we see orbits for these. The D component of the system, the last time I checked, I haven't paid much attention in the last 20 years, but the last time I checked, we hadn't detected any motion. I don't know if anyone's trying. We hadn't detected any motion in the D component orbit around this system, but it shared the same proper motion with the system. Proper motion is how stars are moving, the direction and speed stars are moving across the sky. So we like to talk about the fixed stars, but the stars aren't fixed. The stars are actually moving relative to one another due to us moving and due to them moving, and everything in the galaxy is moving, right? Everything's orbiting the center of the galaxy, and then there's randomized local motion compared to that's just maybe velocity from the birth of the stars, how they were formed, or if they were kicked out of a system or something like that, and then gravitational interactions with all kinds of stuff going on, right? And so it causes stuff to move around. We call that proper motion. How many degrees per second it's moving across the sky. Nothing's moving, no stars are moving a degree per year across the sky. They're moving maybe arc seconds or tenths of arc seconds or less per year across the sky. But one of the ways we like to use to determine if stars are likely to move together in space is if they share the same proper motion. We say they're moving the same speed in the same direction across the sky. Then we say they're probably together. That's how we determine cluster membership for a lot of star clusters. So when we talk about star clusters, we see that. So that's going on right there. You can see that star. So check out that star for sure. See if you can see that star. Great multiple star system to be observing and thinking about. Thinking about star clusters, M48 is a nice tight open star cluster that's about 18.5 degrees. You drop down from Regulus, move straight across 18.5 degrees, and you come to M48 as a nice open star cluster. Good target for your telescope. Above the head of Hydra here, you go up about 5 degrees, and you've got M67. A big old sprawling open star cluster. So it's an old open star cluster. It's big, it's spread out, faint stars. You go up another 5 or 6 degrees and you got M44, the beehive cluster. These are in Cancer. Also a big sprawling but brighter open cluster, closer to us, a younger open, every open cluster pretty much is younger than M67. So a younger open cluster, and you see that one you can actually see with your naked eye. If you got a good dark sky, binoculars will pull that out. So if you start with the head of Hydra with your binoculars and you just scan upward, maybe you see M67, for sure you see M44, I think. So that's what we got. It's a good week. As I said, every week is good, right? If you haven't figured that out from watching these yet, every week I'm metabolizing it. It's got to be a good week, right? And so everything's going on is great. And I hope you have a great week out there. And as always, thanks for watching, everybody.